Welcome to Data Innovation Summit 2018. It's the last panel of the day. I hope you guys have been having fun. We have two outstanding panelists here to talk about IoT. Jon Lindén from Ekkono and Charlie Lagervik from Microsoft. Welcome.
Thank you.
So, tell me a little bit about what you do at Microsoft and Ekkono and how it relates to IoT.
So I'm part of a team that's called the Global Black Belt at Microsoft. So we are a specialized team focusing on different workloads, and my particular interest and focus is IoT. So I help both customers and partners get value from our product and technology, but also helping our engineers understand the needs and build the best products that our partners and customers are looking for from Microsoft.
And at Ekkono, it's all about IoT. We do machine learning for IoT. In short, we say we make connected things smart. And this has a background from the University of Borås, where a guy named Richard Koenig led the research on predictive modeling. And the outcome was a very lightweight software solution, which enables us to actually run advanced machine learning out on the connected devices. So we can see everything, all the sensor data in real time, take instant actions, be independent or less dependent on connectivity, and actually do personalized training on each and every individual separate device. So that's what we do. It's an embedded software product.
All right. Well, IoT is top of mind on everybody.
Yes.
And we've heard it for 2-3 years now at most conferences. IoT is coming up. It's going to be big. It's going to drive lots of internet traffic and that kind of thing. And it certainly seems like it's picked up steam. From my perspective, I've seen at telcos that they've started to make businesses out of it. Has the uptick been as fast as predicted, or is it on track, or is it behind?
I think there's definitely a buzz around IoT with, I would say, higher expectations than we currently see in the market if you look at some aspects of it. On the other side, there's a huge adoption to this platform. I mean, it's a triple number growth for Microsoft when it comes to IoT. It's very fast growing industry. And I think the industry, as you said, if you go to conferences, IoT is generating a lot of interest. And what we are seeing, at least from my perspective, is that we moved away from tryouts and POCs or pilots into real production systems and real rollout. So I would say that we are past the bus, but we still are pretty unmature when it comes to rollouts from an industry perspective. So most of the cases are, I would say, between POCs and real production environments.
That has to be the litmus test, actually putting things into production.
Yeah, definitely.
And what industries do you see being the leaders in IoT right now, in deployments into production?
I would say that it's certainly on the industrial IoT side, and the main reason is money. If you take the automotive industry, a car, it's unfortunate if your car stops and you have to pick it up the next day. But if your truck or your forest harvester actually stops, you start losing money instantly. So it's very much on the industrial side due to money. I very often get the question if IoT is just a buzz. In my opinion, it's not. I would certainly say that this is the fourth screen, but without the screen. That we had the TV, the computer, the smartphone, and now we have everything else that's being connected. And my main takeaway from the Consumer Electronics Show, CES in Vegas, in January was that no one talked about IoT. And I think the main reason is that it's a given. If it's not exactly. If it's not connected, it doesn't exist.
Ubiquitous.
It's kind of like something shouting in the forest. Right. No one is listening unless it's connected.
Right.
So it's a given. And I think that we're going to see a very rapid ramp up, but you have to find the business cases, and that's more in the industrial side right now.
All right, well, let's talk about what's driving IoT. Is it operational efficiency, or is it new revenue streams?
I think it's both. I think there is many of the bigger manufacturing companies, for example, are really looking at building a new relationship through IoT with their end customers and by doing connectivity to their products. But there is also a very cost-driven focus on improving the internal efficiency of the manufacturing environment. So I think there is both an agenda where you use IoT to drive new revenue streams, but there is also that lowering cost perspective to that, particularly around manufacturing. And then when you come to the consumer industry, I think there is still a lot of tryouts to find the right business models around IoT, where data is the new oil, but you really need to understand then what is the oil and how do you consume that oil and how do you present that. So for us at least, I would say that 70-80% of where we see the revenue streams generated for our customers is in the B2B world, and B2C is still pretty small when it comes to real revenue streams for our customers.
So can you give examples of the B2B streams that are...
No, but it's around service industries, for example. So we have Tetra Pak as a Swedish example that are using IoT to provide better aftermarket services for their machines, and also to help the service technicians to remotely communicate and understand status of machines. And I would say that is a pretty common, so to say, scenario now when it comes to manufacturing, where you could use that IoT platform to be close to physical machines, even though you are physically distant from those machines.
Is that why it hasn't accelerated like people expected? Because the consumer end of it hasn't really adopted it as fast as the industrial end?
We haven't seen it as much in the homes as we expected, in the cars and everything else. But just like Charlie's saying, on the B2B side, that's where things are happening. That's where the money is. And my experience when it comes to especially on the B2B side, everyone is very interested in and excited about new business opportunities, new revenue opportunities, but at the end of the day, you buy on threats and issues. How do you solve specific issues? That's what actually generates the budgets, that's where you can get money to spend, and that's typically where it starts. How can we solve a very urgent issue? And something like predictive maintenance is a no-brainer. I mean, you don't want the first call from your customer to be that your machine is broken.
Right.
You want to actually reach out to the customer saying that your machine actually needs some maintenance, and we're going to help you, and we know what you're going to do and so forth. So it's definitely a very good case for how it's being used, connectivity in combination with smartness.
Let's talk just for a minute about what IoT actually is. You know, we talked about before the show started smart TVs.
Right.
You can have these low power devices that don't even use Bluetooth. They use these mesh networks. You can have Bluetooth, you can have Wi-Fi, and you can have cellular networks. What kind of things, when people are talking about IoT, what do they really mean, and what's the bulk of it?
I think you are touching a really sensitive thing around IoT, that there is actually no definition of IoT. So depending who you ask, you will get different answers for that. But for us at Microsoft, IoT is really about providing value by having the combination of the things, the devices, the connectivity to the cloud, where you can take actions from the data that you get from these devices, and then put that back to change the context where the device exists. And I think there is of course the predictive maintenance scenarios around this, but there is also much lower hanging fruits, if you could say that in English, where you just get connectivity and get actually real-time insight to what is the context at the machine. So you don't need to apply pretty much any algorithm, just verifying that this is the sensor value. And I think that is one of the challenges that we see often when we talk about IoT, is that we tend to focus on the more advanced analytic or predictive maintenance scenarios, even though for a manufacturer or for a retailer it might be of huge value to just actually have some verification that this is the status, this is the alarm log, or this is the warehouse volumes that we have in store, for example. So I think IoT could be both those pretty or much more simple scenarios, but it could also be those, I mean, the value increases, of course, the more advanced things you do, but I think often we tend to focus on those, and the maturity might give us a huge value even in the early phases. Right.
I think it's a very broad definition. It basically lacks a definition. That's fine. It's not an industry. It's not a vertical. It's a word that kind of aggregates a lot of things into it. Internet of Things, and that's good. Like I said before, we've taken the step from hooking up people with smartphones to actually hooking up everything else. And this is also where the combination of AI, machine learning, and IoT comes into play. Because with a smartphone, we always have a smart interface, which is the human who's operating it. You have the GUI and you have a smart human operating it. With Internet of Things, they have to become autonomously smart. Otherwise, with billions of connected devices, we're going to spend too much resources on manually supervising and managing all these connected things.
Right.
So everyone's going to work basically in control rooms. That should be the future work for anyone who's a teenager these days, unless we automate it. So we make things slightly more smart, which is a necessity, which is why these two are so closely related.
Right.
But I think also Internet of Things is also actually having things communicating directly with themselves as well. So building these closed, or actually combining those closed control loop systems that the devices themselves could generate if they are close to a machine or close to the device, and then combining that with having that control power of a cloud, for example. So I think what we often forget about IoT is that it's also the Internet of Things. So it should be the things themselves that actually communicate as well.
Right.
And it's not just about device to cloud and cloud to device. It's also between devices, and trying to get a good context of what is actually the surroundings where the devices operate to make clever decisions on the edge. And I think one of the big trends we see now is that you want to combine the power of the cloud, where you have all your data and where you have really advanced capabilities of building algorithms, and then bringing that capability down to the edge or closer to the context where the machines and device exist, and make local decisions where you don't need to loop to the cloud or loop back to the servers to make decisions. And I think we will probably just see...
Is that where things will be moving?
I think it will just accelerate. I think you will see more of that, because the power that you get, I mean, how quickly CPUs and even low power CPUs, how much more computer power you will get on those devices will just, so to say, increase the capabilities that you have on the edge. So the reason for sending things back to the cloud or back to the backend servers will become less and less, and you will use that to have an aggregated view or have a control and have a digital twin that you could then control the devices on the edge. But to actually run the algorithm, even though they are pretty significant, you will probably in the near future don't have that much hardware limitations even on the edge.
It's going to be a necessity that in order to manage this exponential growth in data, you have to take a layered approach. It's not going to be an either or.
Right.
And some things are better done at the edge, some things are better done in the cloud. Like, instead of aggregating 2.5 terabytes of data from an airplane per day, where most of that data is very relevant right now in real time, but the best before date actually exceeds pretty quickly, and where you can actually learn in the meantime and constantly, kind of like a Tamagotchi. The more you feed it, the better it gets. Same thing with a machine learning model. The more you feed it, the better it gets. That actually aggregate the knowledge in that model instead, so you can execute that continuously. That's a better way of processing that real-time data, and you're going to send curated and better data to the cloud, which is better suited for doing cross-referencing. Cross-referencing between your entire install base, like all your trucks, instead of that specific truck. That specific truck is better managed out on the truck, but all your trucks, the fleet, is better managed in the cloud. And also for manual supervision, the cloud is much better. For automation, the device is much better. So it's not, definitely not going to be a versus. It's not going to be an either or. It's going to be a combined. It's going to be a layered approach. It's the only way we can do this.
I definitely agree on that, and I think also where we see limitations now from an IoT standpoint, it's most often not the CPU on the edge, or it's not even the capabilities on the cloud or backend side. It's really networking. So sending data, and particularly if you want to send huge volumes of data, networking is even today becoming the bottleneck. And I don't think 5G or any technology will solve that, because the volumes of data will increase quicker than the networks will evolve.
Absolutely.
So the only way I see this happening in the future is that you need to be able to provide algorithm closer to the data, because you will not be able to move all the data up to the cloud. But you will definitely need to combine these. So you need to train the algorithm, you need to use the cloud or the backend servers for what they are good at, but you also need to be able to actually execute things and react to things quicker on the edge and on the devices. So definitely a combination.
Well, it seems like there's very many different types of devices in terms of their capabilities to connectivity and processing power right onto the device. I heard a neat example by a guy that had a lamp that would tell if it was on or off, and a little bit of intelligence like that, but not quite enough that it would maintain its own state and have a processor in it. Of course, it's just a light bulb. And the best way to handle that was, rather than have a super complicated state machine that would have lots of problems, it would use AI. And you could train the AI by saying good house, bad house,
Right.
when it made mistakes.
Yes.
And that would be an example of processing closer to the data. But how important then is AI in taking advantage of IoT? Is it just about measuring things, or is IoT, this, if we call it like a change, IoT that's coming, is AI an important part of that?
It's crucial. I mean, it comes back to, if you want to do things more instantly. If you just rely on uploading the data and then processing and making decisions and sending back, let's take a truck. They typically upload the data once a day. When we talk latency in the telecom space, it's normally a round trip time. Now we're talking a day. You're looking at a day old data. It's very hard to be predictive when you're looking at old data.
Right.
That's kind of the latency in that context. So there are a few things, some actions, some activities that will require instant decisions.
Right.
And then you want to automate those decisions, and AI, machine learning, is built for that purpose. So it is very, very intertwined. They're very related due to all these different things. It makes a lot of sense to combine AI with IoT because they are so related.
And I think there's also a huge value of trying to document that knowledge. And I think by using AI in the same scenario like you gave us an example, is where you have an operator that is sharing his knowledge around how to solve certain problems, or what does this situation mean, and you get that documented in, so to say, a feedback loop in an algorithm. I think there's a huge value of moving knowledge from the operator into the algorithm, because then the operator could focus on being creative and thinking about the bigger picture and solving real problems, instead of solving problems that could be solved by a computer from a repeatable solution. And I think AI also have, and we see more and more of our customer focusing on this now as well, is that the pace of change is just accelerating. And if you're working with data and you need to understand the data and the semantics of data, customers are now starting to use AI even for the ETL process, so understanding what is actually this data. So AI is even infused in the metadata model generation of the data itself. So it's like, it's AI of AI.
You need a second.
Yeah, it is. And I think this is probably something that also will accelerate, combined with IoT, that you will not have the luxury of defining all the information model that comes from these millions and millions of sensors, but you need to look at what is actually the data, and then try to make estimations from how the data is structured on what does this data represent. And that is where I think we need to have semantic models, we need to have context systems that are context aware and understand the intent of both the devices and the people that want to consume this. And I think that is, we are just in the start of that, and it's going to be really interesting to see how this evolves over the next coming years.
Right.
And I also would like to add a thing when you talked about the case of the lamp, that I don't see it being a big issue with the processing power. This is a question of critical mass.
Well, now it might not be.
Well, no, but the thing is, right now you design product based on the requirements, and if you're just gonna set up connectivity, use Bluetooth to send the data to a smartphone, whatever it might be, then you're gonna dimension the design and the CPU for that purpose. Mm-hmm. If you actually say that, well, it's worthwhile to apply more intelligence, then you're gonna go for a slightly better and slightly, at this time, more expensive CPU, and when that increases volume exponentially, the price drops almost exponentially.
Right.
And then that kind of creates the next generation. So I don't see it as a big limitation, the CPUs that are embedded today, like an M0. Of course, we can't do black magic. There's not a lot of things we can do on that small of a CPU platform. Pretty early up in the value chain, we can start doing things. Then you don't want to do everything. You don't want to run all kinds of deep learning methods on a very small CPU. But you're going to see that they actually push the boundary because they see the value that it's worth to add this cost on the hardware for the premium products, because you're adding premium functionality.
Right. Well, if it becomes an essential part of the product itself, it makes economic sense to move and get economies of scale.
Yes.
But I think that's part of the problem, but I think it's also that traditionally you look at the business case just for the product itself, but the big transformations in most industries is that the services business or the aftermarket business is getting increasingly interesting for the product developers and resellers of products. And meaning that if you have too low specifications on the hardware, you limit yourself on the possibilities on the services and aftermarket business. And I think that is also where we see a change now, that you are prepared to take a risk on increasing the cost for the hardware, because you know that will help you on those aftermarket and services sales as well, to have a higher level of digital and software-based services generated from the devices.
I, for one, was disappointed that my washing machine didn't support plugins that I wanted to add. But
it's probably more about you than...
Yeah, I was going to say.
But, okay, so we're talking about devices. We took a couple examples of devices that are in people's homes, lamps and that kind of thing. What kind of privacy issues are there, both in corporate deployments, B2B deployments, and in private deployments that are specific to IoT? So we spoke a little bit before about data that comes from these devices, such as whether a lamp is on or off. That's not necessarily on its own, without context, private data, or it isn't, for a fact. But in context, it can very easily become,
Right.
and especially in combination with AI, which can analyze the data and make sense out of it. So you had a very nice example that you talked about before.
Yeah, like the automower.
Yeah.
Yes. And the thing, I mean, I love the automower in the context of a consumer case, that I don't want an automower to learn a garden or know a garden. I want it to know my garden. It should know where and when it should operate. I don't understand why I have to program it. It doesn't make any sense at all. It should actually know when it should operate at a maximum and thereby reduce the consumption. So it's going to learn a lot of things, and it's going to pick up things as it's walking around my garden for thousands and thousands of hours. And on top of that, we're going to add functionality. For example, if I switch on like a vacation mode, where I tell it not to go into places where it typically gets stuck, because I don't want it to get stuck, then that is almost the same thing as posting on Facebook that I'm on vacation.
Yeah.
You don't want to do that, because someone might actually pick up you're on vacation, and that might be a burglar. So you're absolutely right. There are cases in context where you have to think about the privacy question. And I think this is another reason why, when looking at edge and cloud, that some things actually should stay on the device, which is my device, and I don't care if it stores it on my device if it's not accessible to someone else. That also applies actually on the B2B side, because we have machine manufacturers and they have their customer, and their customer might be a public company,
right.
And they don't want the manufacturer to know when they have production faults or the production rates. So all the data needs to be processed on premises and just send the conclusions to the manufacturer so they can support the machine. So privacy and information leakage and all these things come into play very much when it comes to IoT and connected things.
And I think that's crucial, really, that you respect privacy and that you are very careful about the data that these devices generate. I think it will be very easy to find scenarios where you will be able to identify persons either in an enterprise context or in a personal context. So you really need to think about that twice, what you actually could do with that data if you start to aggregate it. And I think another part is that if you should trust your operation in your organization to use IoT devices, they need to be secure. And by being secure, they need to be physically secured, but they also need to be good mechanisms to actually monitor what the data is used for and what you do with the data. So I think privacy and security is really, I would say, top of mind when it comes to IoT. IoT will not exist if you don't respect privacy.
That was an interesting example that hadn't occurred to me, was that there can be information leakage, even if it's secure, that if another company can see that your production is down. That's a pretty important insight that you might not want, to leak uncontrolled.
You might be a public company.
Yes.
On the market. So absolutely. But what kind of strikes me is that a year ago, that was the number one question. That was about security. When talking about IoT, that is not the number one question. It's toned down, and I don't know if it's because people actually started to get their arms around it. They haven't solved it. They're starting to get their arms around it.
Yeah.
Or if it's that it's too complicated, let's ignore it for now and let's make sure we solve it later.
I
actually don't know. Exactly. We'll see.
Well, what about GDPR? Has GDPR hit IoT? I mean, is that something people are talking about?
Of course it is, and I think that is also top of mind of many of the scenarios. And as we said, I mean, even though we are in a manufacturing context or we are in a product for B2B, there is definitely scenarios where you need to be careful around what you could do with this data. What data do we actually gather from the devices? Who is actually reporting this data, and could we identify persons? And in most cases you can. So I think GDPR is very important also for the B2B world, particularly because there's humans in these processes, and of course there is also data that is generated from those processes that could reflect what persons do. So I think security, at least for me, I think security still is a top concern for my customers, at least. I mean, in pretty much every conversation we have with a customer, there is questions around security, and it very much comes down to building that trust on the platforms, and how could we, from a Microsoft standpoint, deserve that trust from our customer. And for us, it's security, but it's also transparency. So being very transparent how we store data, where we store the data, and being very clear that the data is owned by the customer and not by us. It's always the customer's data. And I think that is when you start to have, if you take a manufacturing environment where you have those value networks, you need to be careful also around the insights that you actually could get from about the other actors in the value network. Like you said, that if you are a supplier of parts into a production, you could start to see from how the parts are being used, how is the business or the production going for other actors, and if you just get data from screwdrivers, for example, in production, you could start to analyze that data and actually understand how many faults do they have in their production environment. Right. So I think GDPR and I would say also information security, you need to think carefully about that, because it's not just about the data you get, it's also from the insights you could get from that data, and how you could spread things around that data, so to say.
Right.
So.
Well, transparency is very important, and I was speaking with Jean-Michel Franco from Talent this morning about GDPR in specific, and he said that one of the main things that will help you avoid litigation is being open and honest, because it's not clear whether you're compliant or not, and so reducing your attack surface is being open with exactly what's going on with the data, how you're handling it, and what you're doing. I have to say, I was personally disappointed this week because I figured out that my car, I had unknowingly opted into selling all my location data with the connected car to third parties. I probably would have gone along with it if I'd known about it, but it bothers me that I didn't know about it. That's more of an issue than actually sharing the data for me, because, well, I expect them to take the data, but the fact that it's not clear makes it a bit bothersome.
But I think that's a good example how it shouldn't work. I mean, you need to be transparent about what you do with the data, and that comes back to the trusting as well, that if you should deserve that trust, you need to be both transparent, but you also need to be able to actually be certain that the data is secure. So you don't want the data to be taken by somebody else that had other intents than the ones that you have accepted for the data to be used in. So
I also think that what we are talking about, we are talking about digital transformation, and transformation of a lot of old traditional companies that are very strong with the domain expertise in a certain area. They have great products in that specific area, and now all of a sudden they're going to become digital. They haven't had a data-driven business in the past. So for them, this is going to be a radical change, and of course, this might not be top of mind, and it's complicated for all of us to really understand the impact and how to act and manage when it comes to GDPR and other things. But I think it's probably right. Transparency and thinking about it, working with it, and trying doing its best is a good start.
5G is hip. 5G is big. Is it coming soon, and is it going to affect IoT, or is it like any other connectivity before it?
It has to, but it's a technology, and that's the thing. Like all of us, well, it is. Every generational shift is pretty revolutionary, because they're not like slowly. They're jumping incrementally, and then all of a sudden that changes the circumstances, the conditions, enabling us all of a sudden to do full HD when it used to be that you were doing pretty poor SD in the past on TV, and then being able to do 4K, that it actually enables you to do pretty radically new things. It's going to be the same thing with IoT, that we're going to see all of a sudden that some of these use cases that are very data intense will be enabled by connectivity.
So will my Skype calls be a bit more solid from now on?
I don't know, probably, hopefully. but there are a lot of moving parts in this equation. It comes down to the software vendor, to the network, to the operator, and all these different things. And I think, like Charlie said before, that it's going to be the network that's going to be a bottleneck in many cases, because we're going to find ways of consuming that extra bandwidth. We've always done that.
Yeah.
Every incremental step, we found new ways of consuming all the available bandwidth and doing new things that requires a 6G and a 7G. And in my opinion, 5G is definitely a very interesting and important step, but it's just technology.
Right.
And I think what's interesting is 5G combined with other narrowband technologies, etc. Because what I think is really interesting to see now is that we are starting to get all kinds of different connectivity standards and capabilities in place. So if you have an IoT scenario where you just want to have very small data volumes once a day, but you want to have long battery times, there is technologies for that. If you want to have your virtual reality model sent over 5G to your HoloLens from IoT devices, you could do that as well. So I think what is interesting is now to see that there is starting to become a bigger variety of different connectivity platforms, both from a business model perspective, where telcos are being challenged by some of the narrowband technologies like LoRa or Sigfox, for example. So I think that kind of a competition will probably be good for IoT in general, because that will push also all the other actors to actually move forward. But I don't see that 5G is revolutionary by itself. I think the revolution is by enabling those new scenarios.
New types of services.
Yeah, definitely. And there is scenarios today that we can't do because we don't have the data throughput in the cellular networks, and 5G will definitely unblock those. But I think, as I said, I think the requirements and demands will increase quicker than the standards will be there. So I think we need to find other ways also to still do workarounds, even though we have 5G, because that will start to be a limitation as well when we come forward. So.
Video games and entertainment always manage to push the market forward.
Yeah.
Yep.
Well, I think one question that our viewers have been hoping for the entire day, we haven't really spoken about it, so I'm wondering if it affects IoT, and that is blockchain. Blockchain technology. It almost, I resent almost having to say just blockchain because it's such a catch-all nowadays, but I think that there are perhaps some use cases when it comes to tracking items and that kind of thing. Do you see that there is an intersection with blockchain technology and IoT, or is that just two hyped up things in one place?
I think it's a strong buzz around blockchain, no doubt about that. And we have done some tryouts, or have customers that have done some tryouts. The limitations we see with blockchain today is really the transaction time that it takes. If you have big volumes of transactions where you want to secure them with blockchain, we see transaction time actually being a blocker. But the concept itself is really interesting to actually have trust entities that together themselves could agree on what is actually the trust base that we have between each other in supply chain, for example. But at least from my experience so far, I think it's a little immature for having at least high volume transactions because of the transaction time. That's my perspective to that, at least.
I'm a startup, so I have 2 out of 3 buzzwords in my bingo. So I have IoT, I have AI or machine learning. I would love to have blockchain. No, but seriously, I think that in comparison to 5G, for example, this is more of a concept than technology.
Right.
And there are a lot of very interesting conceptual things when it comes to blockchain of removing a trusted third party.
Right.
That becomes like a central party. And especially in times like this, when politically we have forces around the world that might not be trusted parties from a political point of view, that are sitting in very strong power positions, then actually distributing the power to the people is a very compelling value proposition. And so I love the concept. I think that it's gonna actually generate some very, very interesting evolutions of business models and actually create some really, really cool things when it comes to how that concept is being applied.
Yeah.
So I hope for it, but still it's a bit immature. We haven't seen much of it. We don't work exclusively or specifically with it.
Well, I think people are seeing both the benefits and the disadvantages, and it's probably only highly technically savvy people that have been able to use it, which is why they only see the advantages. A lot of people probably need the hand-holding that a trusted party in the middle provides, such as the ability to reverse transactions and that kind of thing. And so maybe it's not possible that everybody uses these fully autonomous, fully trusted distributed systems. I guess history will tell.
Absolutely, but the thing is also just like IoT, why is it happening right now? Yeah, the price on sensors and CPUs are going down, all these different things. But it's also because everyone's talking about it, that we kind of generate a momentum that sets this snowball rolling, and all of a sudden it starts happening, and it starts happening at scale. I mean, there's not a single CEO out there who can ignore the threat of technical disruption.
Right.
They used to be able to discard and say that, well, we've been around for 150 years. Nothing can bring us down. No one is actually being that disruptive in our industry. And then they've seen all these examples of anything from the music and video industry to whatever it might be. Everything is being disrupted. So once that momentum starts going, then all of a sudden everyone starts looking at this, and then they start putting in the domain expertise, and then they start doing things. And I think this is a very important thing when it comes to IoT, and especially in the combination with machine learning and AI. Do small wins. Don't try and boil the ocean. That a lot of these things that we talk about are grand, tremendous things that you would love to do. But at the end of the day, start small. If you can actually solve a small, like we have Alfa Laval as a customer, we look at 4 or 5 sensors, figuring out when you have to do maintenance. And they have maintenance cycles of anywhere between 6 weeks and 5 years. So of course, if you can learn individually for each and every heat exchanger when you should do it, based on different conclusions, that's extremely high value, and it's pretty basic as a use case. But it's very valuable. Small wins.
Well, I've asked other panelists earlier today what reasonable cycles are for projects. And we have our idea. You know, we do big data and machine learning consultancies, and we think if a project takes a year, it's often the case that at the end of the year, you don't even remember why you started in the first place, you know, and that kind of thing. So what do you think are reasonable timeframes for having these projects? These are words that have come up time and time again today in our panels: speed, collaboration, executive sponsorship. So I like that you said small also, so I'll combine that with speed there. What kind of projects are we talking about? How big should they be in order to make them successful?
You're absolutely right. If it takes a year, that's an eternity, especially for a startup. I can go bust in a year. I mean, we need to go where the money is right now, where things are happening. Right. And I think that this approach of thinking like a roadmap, small wins, you add constantly new features, and they're not used to that. They're used to having a machine, and then they do the next generation of that machine, which is within the same silo, within the same part of the organization. Now they're doing a digital transformation project that goes cross-functional across the entire organization. They don't have the processes and the people for doing that. So they don't have the playbook.
Right.
And that kind of stalls it. But if you can actually break it down to say, you know what, let's just do it for the heat conversion. Let's just find one issue that we solve and just push it out. It might not be as beautiful as we want it to be, but that at least gives executive sponsorship to take the next step and the next level and getting the people involved.
Time. 3 months, 2 months, 1 month,
Well,
how long?
I think it very much
What's
depends.
reasonable though?
But what I see is that we are moving away from doing investigations, of doing POCs or pilots where you really want to try out the technology, because that 3 years ago that was a pretty common thing. We actually want to evaluate the technology, and what is happening now is that the technology itself is maturing so quickly. So if you do these kinds of evaluations, what you actually concluded as a result from that is not true anymore, because there's happened quite a lot of things during the 3 months. So I would say, agree with you that you really need to keep it small. You need to start with what is the requirements that you're looking for the next, I would say, month or 3 months. I think that is a pretty good
1 to 3 months.
Yeah, I think that is a pretty good time frame to focus on. And then you could have ambitions. What is my 1 year ambition? But when 1 year in this world now it's a lot of time, because there will be so much innovation coming from a technology standpoint. Your competitors in your industry, wherever you are, will have changed quite a lot in the next coming year as well. So your requirements on your business and how you should position yourself will most likely have changed as well. So I think, don't think too far into the future, because you don't know what the future look.
Right.
Prepare for change, because you definitely need to be able to change. And look what you really could affect in the next coming month. I think that's a best practice for IoT.
Right.
Yeah, I was going to say the same thing. 8 to 12 weeks. That by then you should have something that you can show that can if not be a publicly launched product, at least it can get internal buy-in. So take that approach. Because what you're also going to do is that you're going to learn so much in the process that you're basically going to redefine the product in many cases. That, wow, what if? And then you're going to figure out that I actually would like to have these sensors as well, because then I could. And then you get someone else who kind of throws something into the whole idea, and then it kind of evolves and becomes something else. And then it's better to transform with that and end up with a better product than doing all the rigorous processing and delivering a perfect product that is way too late and was perfect theoretically, but not in reality.
This is quite a far cry from the ERP projects that were 3 years plus and that kind of thing. I don't think a lot of organizations are ready to mobilize. I know we've had customers where they've said, 1 month, that's awesome, let's do it. And then we start, and where's the guy that knows this? And then the month is over and they haven't even been able to get their data, and how can we work?
Well, that's why you need a solution partner. You need someone who actually owns the solution, and then use technology that is flexible, and that's what we're seeing. I mean, on the IoT platform side, we're basically seeing Azure and your other competitor from Seattle. That's what we're seeing these days. That because it's programmable, because you don't know if you actually buy functionality when you finalize that project. In many cases, you realize that was not the functionality we were looking for. So you're looking for a very programmable environment, and that's also what we bring in. We bring in a programmable edge computing solution that you can configure, add more, and kind of develop based on a roadmap. You want to configure it because you're going to find out things in the project in those 2 to 3 months of what you really want to do, and then you want to be able to shift slightly direction to get to where you want to go.
Well, I think it's beyond doubt that the cloud is ready to rock right now. And the question is, data governance and all that kind of thing, is that going to set a stop? I mean, are you going to be able to find the people that are responsible for certain data streams, getting the people together to collaborate? Or what do you see as the greatest hindrance to implementing a good IoT strategy?
I think it doesn't have much to do with technology at all. I think it's still the culture thing. I think it's that you need to have the right people in your organization to actually have a different way of work. You need to look at your processes. If you are an enterprise, I mean, the capabilities that IoT could provide when it comes to having the telemetry from products, having that insight on how your customers are using your products, you need to change the way you work internally on reacting to that data to make that data valuable for you and then generate increased value for your customer. So I don't think it comes down to technology by itself. I think it's very much a culture adoption from an organization, and I think that is the main reason that IoT projects stall today. It's not that you have, I would say, data issues when it's data quality or even technology. I would say it's much more the people and culture readiness who should own this solution. How should we drive this as a product? How do we drive this as a service? And I think that is where we see most of the blocking happening today. It's not about technology itself. I think technology today is very mature, even though it changed quickly because we add a lot of innovation both on the cloud side and on the device side. But I think where we really need to step up is on how we adapt and how we are flexible about adapting from an organizational standpoint. So I think that is, it's more about the people and the business than it's about technology.
All right. If we step back a little bit, it's the last panel for the day. I want to talk about something that is that I find quite interesting. because I work with it, and that is smart cities, devices, and all that kind of thing. What kind of momentum do you see with regards to smart cities? Is that happening, or is it still far ahead of us?
I think that smart cities for me could mean quite a lot of different things. It could mean that the society around the city use open data to get insights around the data that is run in the community of the city.
With regards to IoT then?
Yeah, so it could also be that you have, for example, smart traffic lights and you have those integrated systems,
right,
etc. And I think we are in very early phases of making that happening today. And I think the main reason there is that we have too many standards, or we lack agreed standards. How do we actually exchange the information between these, in many cases, legacy systems with new IoT platforms? And I think that is, in those cases, it's very much down to building the information models on how we actually could get data and understand data, and how we could compare data and make that as easy as possible. When it comes to buildings, for us now, it's just exploding the interest around buildings. I did a session on
sensors in buildings?
Yeah, and it's not just sensors, it's also around that buildings are, the environment around buildings are changing, that in the sense that if you look at an office, for example, it's becoming a place where you don't have your fixed table and you are sitting at your workplace. You actually want to have different environments. You want to have somewhere where you could concentrate, you need to have somewhere where you could be creative and where you could have team meetings, etc. And all of this, you could make a better decision around where you should be if you have data that support your decision making. And if you are a retailer today, the physical store is becoming much more of an arena for an event than actually a showcase of your products.
Right.
And retailers are also increasingly more interested in getting data around what is actually happening in the building, and what is the dwell time of the people, where does people stop, etc.
Mm-hmm.
And I think for that reason, now combining also the core data that you have in buildings, like ventilation, alarms, and passage control systems and everything. If you combine all of this, you could start to make really clever use of your buildings, lowering energy consumption. And I think this is scenarios where it's really exploding if you look into the building. So what I expect as a next revolution is that when you start to set those standards now, is that buildings, you could start to have communication between buildings as well. So this world of having a control inside your building will open up, and then you could start to look what is the spaces that are around my building, etc.
Right.
But I think we are still in early phases of this, and it will be really interesting to see how this evolves over time.
I agree. I mean, buildings, that's more of a contained environment. You have less dependencies on other parties. That's the thing with smart cities. You have a lot of dependencies.
Right.
And I think that there are actually, if we look at Sweden, I think that there are some learnings we could actually take from the metro networks, mm-hmm, that we started doing some 20 years ago, where you started building out some infrastructure. And then those that were most successful actually had their own customers, like other municipality-owned operations that actually became customers. Mm-hmm. And then that kind of justified the investment, and they started actually being used, and when it starts being used, then it starts becoming real, and then you actually face all the real issues, and you create a solution that works, and then others can tap into it. That kind of creates the momentum. But there are a lot of dependencies, which is why it's going to take some time. There's a lot of opportunities. There's a lot of very interesting things and cool things you could do in terms of smart cities, but it's going to take some time. And I think once again, small steps, and bring it down to a certain level, manage expectations, because then eventually, when everything's built out, then you can actually hop around and have the same expectations on all the different cities. It's kind of hard if you have a car that depends on smart parking and whatever it might be, open data from smart cities, right, and all of a sudden you drive into a city that has nothing.
Yeah, that would be disappointing.
That would be disappointing. So I think that's the big challenge, that you have a lot of dependencies.
Right. We have a customer here, for example, Lagervik, that were showcasing their solution for distributing heating, where they saw huge business values of communicating actually with the houses to understand what is the pattern at each of the houses, and when do they need heat, and then understand the grid of that distributed heat. Where do we lose energy, and what is the energy that the houses need? So when you could start to use those predictive analytics for the infrastructure of a city, there is a significant savings that you could do around both detecting waste, so see if we actually have a leakage because we didn't know this before, but also being smart around how you generate and consume, for example, heat in a city. So I think there's a huge potential that we need to establish these connected ecosystems around cities, because that's the only way we could meet the requirements of urbanization together with having less resources to actually manage the city. So we need to be smart around that, and for me the answer to that is really to have connected platforms that could use smart algorithms to understand and control those systems. So.
Right, makes sense. Well, that was all the time we had for today.
Okay.
And that was the last panel for the day. Hope you guys enjoyed yourselves. Hope you'll be back next year for Data Innovation Summit 2019. Thank you, and I'm signing out.